Hey, good morning, everyone. This is Mr. Vo. Just wanted to highlight a few things from, let me just move this up real quick, for today, because I'm not going to be here. I'm not sick. Just got to take care of my journalism class. So anyway, I want to go over all the things that you need to do today. It's going to take a little bit, so I'm going to add little sections for you to breeze through. So the first thing that you're going to be looking at is your warm-up and the agenda, okay? So the warm-up and the agenda is pretty self-explanatory, right? So you're going to load that up, check out it's slow as my computer is chugging along, but it's pretty basic. Look at that. Look how slow that is. All right, I'm just going to close this right now. Close. Come on. Okay. So the first question is, what is the law of conservation and what are the 5 signs of a chemical reaction? So the goal for today is all these, what's it called? Review questions, right? So the law of conservation of matter, let me annotate this real quickly. This brings me back. Law of conservation of matter. Matter is neither created nor destroyed, but rearranged. So that's the most important part, is a rearrangement of matter, right? You're not creating new things or old things, right? It's just different things that are using a combination of that matter. So in chemistry, that means that the atoms in a reactant, in a chemical reaction, is the same as the atoms in a product, okay? The second question you can probably do on your own, so I'm not going to go over that. You need to answer this for credit. Okay, I'll look. I will look. Okay. All right, so let's check in with the notes. Okay, on EQ1, I'm going to switch to EQ1 right now. On the notes, and obviously these are, okay, so everything, this is like a blast from the past. So this is easy review. So I will go to what I think might be important. Okay. All right. So, or that might be new to you. Okay. So over here, it's important for you to look at, let's see, how we figure out the law of conservation of matter and mass in terms of reactants. So I'm going to go to, I skipped ahead too much. Coefficient, subscript, and superscript. So coefficients, as you might notice, are over here. That's the coefficient, okay? So coefficients are the large numbers, subscripts are the small numbers, and superscripts are these numbers, okay? So that is a coefficient, that is a subscript, and that is a superscript, okay? It looks really ugly, but you can probably do a better job than I can. All right. So far, so good. Let's move on to the next one. Yay. All right. Coefficients apply to every element or ion or molecule to the right. Okay. Chlorine, the subscript applies to every element that's to its left. Okay. And then the plus, the ions are not involved in counting. So you got to make sure that. Additionally, if you have a subscript that's near parentheses, it applies to every element. You multiply that to every element inside the parentheses. So that means you have 3 oxygens and 3 hydrogens in here. Okay. So here's the example, right? You got 5 as a coefficient. There's your 5 multiplier. Now you start counting the number of atoms, right? So the aluminum is right there. Sulfur, there's 1 sulfur, 4 oxygens, you multiply that by 3, and then you multiply everything by 5, right? So this is 12, this is 3, this is 2, right? So I have 85 atoms in there, okay? All right. So over here, let's do this on our own, right? I got 6 aluminums. No, not 6. The 6 is a coefficient. I'm going to make that, multiply that by 6. It's not super clean. That's okay. I got 1 aluminum, and notice the 3 needs to apply to the 1 oxygen. So that's 3, and that's 3. Okay. So the total, you got to figure it out. I won't tell you. So I don't want to, but I'm not. You figure that out on your own. Okay. The rest of the notes are pretty straightforward, except for the last part. Okay. You got so take all the notes, and then erase everything. Okay. So over here is the law of conservation of mass. Okay, the law of conservation of mass tells you that mass of the reactant has to be the mass of the products. So anytime you do one of these problems, I want you to pay attention that you've got the same amount, right? So notice that this over here, you made 243 plus 71 grams of CbR2 plus CO2. So there you go. So that totals a certain number. 243 plus 71 is, calculator, 243 plus 71. You got 314, right? So 154 plus what will give me 314? And the answer was 160, okay? All right, I'm gonna move on to the next part, and that is the Magnificent Seven. So you've got non-metallic elements that form molecules with themselves. So that means that these, you need to memorize these. I'm gonna highlight these, memorize. Oh, look at that, it looks cool. Okay, and I'm going to tell you how easy it is to memorize, but I'm going to also emphasize that the first one is that they are easily bond to themselves because they only need the amount of molecules that they have with each other. So fluorine has 7 valence electrons. So it has 1, 2, 3, 4, 5, 6, 7. So it needs 1 to share. Guess what? Its friend, the other fluorine, has 1 atom. It has 1 electron to share. Ta-da! It looks like it's going to form a single bond. And that's the same with all of these. This has 2 electrons left. It can have 2 bonds, okay, with itself. So that's the reason why, but I'm going to give you another easy reason why that you can memorize this very quickly. So on your periodic table, check this out. You got hydrogen, oops. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. That is equal to, that looks like a number 7. Kind of weird number 7, but it's a 7. Right, trust me, okay? So there you go. That is what we call the Chemnificent Seven, okay? So HNO, Bl2, Cr2, O2, N2, H2. All right, and I2, okay? All right, so I'm going to move on to the PhET activity, all right? Hold on, there's the PhET activity. There it is, okay? The PhET lab, and then over here, let me just close this real quick. Sorry, this is slowing down, I'm sorry. Everything is very slow. There's a Chemnificent 7. Okay. So over here, you pick up a little sheet. It's also in the Canvas as well. Okay, so this Fed activity is very useful, I believe, in helping you differentiate between law of conservation, matter, and mass. I'm going to play this. I'm going to show you what to do. I already wrote the answers to 2 of them, but I'm going to delete that just so you know what I'm talking about. Okay. All right. So for this one, you're trying to make ammonia. So notice that the ammonia is over here. Here's ammonia right here. Okay. So I got to balance it just like I did with the gizmos activity, right? And I'm not sure what I'm doing. Oh, I do. I pretended. Okay. So you realize that this is balanced. And there's a few ways for you to understand that it's balanced, right? So there is the scale and there is this graph, right? There's a scale, there's a graph, and there's smiley face. There's 3 ways for you to figure this out. All right. But I want to emphasize that molecules are groups, right? So you got N2, you got 1, 2, 3, 4 molecules on the reactant side. So I would write that 4, right? 4 molecules, right? On the reactant side, this is in the lab. Okay. On the product side, you got 1 and 2 molecules. This is different than number of atoms, right? Atoms are those individual elements that you can see. In ammonia, if you can check, you got how many atoms? So it might be helpful to look at this graph. You got 2 atoms here, 6 atoms here. That's 8, 2 atoms in nitrogen, 6 atoms in hydrogen. That is also 8. See, that's not too bad. Everything else is pretty self-explanatory, right? I really encourage you. You're going to finish this. It takes like 15 minutes to finish. Okay. And for gizmos, the gizmos activity, you'll be finishing that up until page 4. All right. Part D, or no, part C is optional, but I think it's extra credit. So if you want to do that, that is more power to you. Okay. So I'm going to open up that real quick, the gizmos. Just know that all you have to do all the way over here, right? To 1, 2, 3. When you balance everything, remember that you do not balance the what's it called? The subscripts. Okay. So the goal is to not balance the subscripts. Okay. Part C, if you know how to change the gizmos to mass, I think you're on the right track. Okay. All right. So far, so good. Let me know how you're doing. I hope you guys have a good day, and I am looking forward to seeing you on Friday. Bye, everyone.